This lesson extends the ideas we've had about graphing, and it assigns it to how we solve systems of equations. Our objective is that we can solve a system of equations using graphing. So first of all, let's set up our two-column notes, our Cornell notes. We're going to draw a line underneath the topic to set this up. We're going to draw a line down here. Now this doesn't go very far. Notes will be a little shorter today, and instead we're going to be using, doing a lot of examples to help illustrate what we're working on. So when we do these, I want you to make sure you pay attention to the detail be very precise on your graphs. It's very important. We're going to use our graphing calculator, but when you transfer it over to the graphs, you have to be precise on the ordered pairs that you list. So first of all, solving a system by graphing, you basically graph and look for the intersections. It could be one intersection point or it could be multiple ones, so I put intersections there. So if I've got, for instance, if I've got a line that I graph like this, and then I graph also a parabola, let's say like this, you graph a parabola, then what you're looking for the solution are the 2 points there where they intersect. If it were two lines, or they would just intersect in a point, this would be an example of where a parabola and a line intersect in 2 points. Now it could be that they don't intersect at all. Let's say I took this line and went down here where it never intersected with it, then that would be no solution. So be aware that there are those possibilities. Okay, let's go ahead now and look at some examples. We're going to use our graphing calculator for this. So our instructions are to graph both sides of the equation. We're going to do this side and that side separately, graph them, and then find out the x value where they intersect. That will be the solution for the x. The solution to the system will be the ordered pair. Okay, so to solve this, and by the way, you know how to solve this, so let's go ahead and do that first, just so that you see what the solution is, and then we'll see how the graph applies. So we're going to add x to both sides. Remember, you have to do to one side of the equation what you do to the other. So you're going to have 4x minus 4 equals 8. Now you're going to add 4 to both sides of the equation. So you get 4x equal to 12. Divide both sides by 4, and you get x equal to 3. So we should see the intersection come where x equals 3. Let's see if that works out. Let's go ahead and graph this one here. So I'm going to go ahead and put it in my graphing calculator. So I have I'm going to set up a table for it. That's the way we're going to be using our graphing calculators. Put it in here and then take a look at the table. So I'm going to clear this off. I'm going to put in 3x minus 4. And remember, as I do this, if you changed your window, remember you can always hit zoom and then down to standard, and that will give you the same graph like this that goes from -10 to 10, -10 to 10. All right, let's put into the next one. Don't erase this one. Instead now, let's put the second one on the second line. And so I'm going to have 8 minus x, so 8 minus x for this, and then I'm going to hit graph, and I'm going to see where these two, notice they cross right there. Now let's go ahead, if I do my table for this, notice that I can go ahead and just put in these values. 3 minus 4 is equal to -1. 2 times 3 is 6, minus 4 is equal to 2. 3 times 3 is 9, minus 4 is equal to 5. 4 times 3 is equal to 12, minus 4 is equal to 8. The other way to do this graph is, remember, but to do it using the y-intercept and the slope. So another way to do it would be to start at -4, and then I would go up 3, 1, 2, 3, and over 1. That's my slope of 3. You make it 3 over 1 to make it a fraction. Notice that that's the point 1, -1. So I go up 3, 1, 2, 3 over 1. Up 1, 2, 3 over 1. There's my point 3, 5. Up 1, 2, 3 over 1. So there is my graph of this line. Let's do the other one. Now the other one, we go ahead and if we put in these values, you put in 1 for x, you get 8 minus x, you get 8 minus 1, you get 7. 8 minus 2 is 6. 8 minus 3 is 5. And 8 minus 4 is equal to 4. So if we plot those, let's go ahead and just plot those points. We want to be precise. Remember that's 1, 7. So you do 1 for the x and up 7 for the y. You do 2, 6 up here. 3, 5. Notice that's exactly the same as the other graph, and then 4, 4. So when we graph this one, notice our intersection is this point here, where my x equals 3 and my y is equal to 5. It's the same on both of these tables, 3, 5. So when I do an equation, and if I look at graphing both of them, both sides, and I were to graph both sides, I'd see the intersection. I'm just looking for the x. But if I'm going to find the intersection of this system where these two cross, my ordered pair would be 3, 5 for the solution. Okay, so that's two ways to look at it. All right, let's do this this parabola, the next one. All right, so this one I'm also going to enter in my graphing calculator. All right, so in this one I'm going to use the table from the graphing calculator. So let's go ahead and put y equals, I'll clear this one off, hit enter, and clear that one off. So I'm going to start with just graphing this one, x squared minus 10. So you hit the x, over here's the square on this side over here, and then you can put minus 10. And let's go ahead and see what that graph looks like. All right, so we've got our parabola. Let's go ahead and look at our table, second table. We'll fill in this table starting at -3. So -3 gives me a -1. Okay, and let's just get a few at a time here. So the next one, notice -2 gives me -6, -1 gives me -9, 0 gives me -10. So -6, -9, -10. -6, -9, -10. Be precise on these and writing them down. Now what's nice about this next part, what we see with parabolas is because you have one side and the other side is a mirror image, we're now going to see a mirror image of values here. Notice that it repeats with the, as we go down further here, down beyond 0, notice that you see a mirror image, -9, -6, -1, etc. So I can just repeat these values, -9, -6, -1, and then the last one that we get from a 4. If we put in 4, let's do that. 4 squared is 16 minus 10 is equal to 6. So let's plot these points. -3, -1, so over 3 and then down 1 for that. -2, -6 is right there. Okay. -1, -9 is right there. 0, -10. So notice x and then y for our graph. Make sure you're precise about it. Then we're going to do 1, -9 for the mirror image. 2 will give me this a -6. 3 will give me -1. And then I'll add in the 4, goes up to 6 up here. So if you look at this graph, it looks like this through these points. Okay. Now let's do the 2x minus 2. See where that one goes. So I'm going to graph that one separately. So if I look at this one, I'm going to go ahead and clear this off, and then do 2x minus 2. And then look at the graph. This is what the graph looks like. Let's go ahead and look at our table to fill this in. So our table, if we start at -3 for this, starts at -8. And the nice thing about this one is, if you look at that table, it goes up by, because our slope is 2, it's just going up by 2 for each number. So let's just fill out the chart, go up by 2, we get -6, -4, we get -2, 0, 2, 4, and 6. Okay, so that would be our values from the table here because of the slope just moving it up by 2 units each time. Now, let's go ahead and plot those. I'm going to plot that in a different color. Let's do this one in purple. So -3 over here and -8's down here. Then we go -2, -6. That looks like a crossing point right there. -1, -4. And I go with a 0, -2. By the way, we can use our slope up 2 over 1, and we just keep getting those points, up 2 over 1 and up 2 over 1. And that just gives us those values if you use that slope. Notice that's like starting at the -2y intercept and going up 2 over 1 for each of these, if we did it by hand. So there is my graph. Notice that here are my 2 points of intersection. On my table, that's right here, -2, -6 is the same as this -2, -6. And then on this other one, out here at 4, notice that 4, 6 and 4, 6 are the exact same point. So to solve this equation, basically it's those x values. The answers to this would be x equals -2 and x equals 4 to do that graphically. So you just graph each side, look for where they cross, and take the x values since there's only x's in that equation. If I'm solving the system of equations, the ordered pairs, -2, -6, are my solutions. So we work more with those in the next couple days is to give both the x and the y values for that. Let's go ahead and change that. So -6. Oh, that's a +6. Okay, so on this one, this ordered pair is going to be 4, 6. Okay, I'll put it up here by this one. Okay, so those are my 2 solutions to the system of equations of these 2. This is the solution for when I have just the x's for it. Now what we're going to do is we're going to, this is what the new material is. Let's go ahead and do some review just so that we're keeping track of some of the topics we've already done. So just a reminder of graphing some of these. We want to be precise in our graph, do domain, range, min, max, decreasing, increasing, and then we're going to do a piecewise function just to review, okay? Looks like these letters should have been different. This should have been a C, this should have been a D, and this should have been an E, okay? All right, let's go ahead and put that on a graphing calculator and graph it. All right, so we're going to put in that equation, go to y equals, clear this off. I'm going to put in 2 times parentheses, x minus, so here's my x key, -3, end the parentheses, now put a square on it, my square is over here, squared -5. And here's what the graph is going to look like for us. Okay, so it fits in our window, we don't have to change our window for it. Let's go ahead and set up a table for it just so that we get an idea of what this table looks like. You might remember that this, from our translation problem, this moves the x value over in the opposite direction, so it moves it over a +3. It's going to move it over to 3, and then this moves it down 5. So over to 3, down to 5 is that point right there. That's critical. I'm going to use that point 3, -5 to kind of be the center point for my chart, my table, for the parabola. So if I look at my table, and let's go find that 3, there's 3, -5, and I'm going to use that in the middle. So I'm going to put between 3, -5 here, I'll use 2, -3, and 1, 3, so 2, -3, and 1, 3 on this side. And then on the other side, see, look at the symmetry involved. Okay, so we're going to have, on the other side of 3, we'll have 4, -3, and we'll have 5, 3. Let's plot those points and draw our parabola. So we're going to do 1, 1, 2, 3. And we're going to do 2, -3. It's right there. And we're going to do 4, -3. And then 5, 3. So there's our parabola. Okay, we've drawn it precisely because we came up with points from the table, plotted the points and graphed it. What's the domain? We're going to do this in interval notation. Just a reminder that this graph is going up forever, but even though it's going up forever, it's staying narrow, but it never goes vertical. It keeps getting wider. So the domain, it keeps going to the right and it keeps going to the left. And so our domain is going to be -infinity to infinity. And you're going to find that's the pattern with parabolas, unless we restrict the domain, which we will down here on the when we do the piecewise function. But unless we do that, the domain is oftentimes all real numbers, this -infinity to infinity, putting parentheses on the infinity. What's the range? Well, it goes up forever, but the lowest is -5 here from my table. So I get to -5, that's my lowest point, but then the highest it goes up to is to infinity, and we always put a parentheses on that. What's the min or max? Well, notice there is no max because it goes on forever. This point down here, though, is the min. So I'm going to say that my min is the y value at that lowest point. So my min is going to be, min here, minimum value is y equals -5. Okay? What interval is it decreasing? Notice it decreases on this half of the graph and it increases on that half. So decreasing would be from -infinity until we get to that x value of 3. So -infinity, then to 3. I'm going to go ahead and highlight that. Let's highlight that in blue here. So this is the part that decreases from -infinity all the way to that x value. It doesn't include the 3 because then it changes direction. And then we're going to increase out this way. Okay, so it's my increasing part. So the interval it's increasing is it starts at 3 and it goes off to infinity to increase. So that gives a review of a lot of this information on our graphs. Let's go ahead and do this piecewise function as a review. This bottom part here where it says solve the impossible equation, we'll do that in class. So for right now, let's go ahead and solve it or graph this piecewise function. So remember, a piecewise function I like to do in different, I'm going to do it in different colors just to help us see. Y equals 4 is the first part. That's a horizontal line. Whenever you have just a number, it means horizontal. So y equals 4 is going to be a horizontal line here at 4, and it's going to stop when we get to -3. So as you get to -3 here, I'm going to do an open circle. Oh, I'm going to do a closed circle because it's or equal to, and I'll have that part of the graph. Okay, so or equal to closed dot. Now I want to do the next part. I'll put in green. Now this is an interesting graph. This is going to be a parabola, and I want to go from this point to that point. Now remember what this parabola looks like. If you want to look real quick, it might help to just do a quick graph of it on your graphing calculator. So we have x squared minus 5, x squared minus 5. If you look at the graph, it's just a graph that comes down to -5 here. So what I would recommend you do with these middle parts where it has 2 points here. I would recommend you put in the -3, see what that value is. So -3 squared is equal to 9. 9 minus 5 is equal to 4. So -3 comes up here to 4. I typically would put an open dot there because it doesn't include it, but this one already filled it in. That's kind of an interesting little fact on this one, is that it's been filled in by this one, so I'm going to keep it filled in. This other endpoint for 2, I'm going to go with 2 over here, and then put in 2 squared is 4, minus 5 is -1, so I'm going to have 2, -1. I'm going to put an open dot there, and remember what our graph looked like. It came down here to -5, and then it's a parabola up to the other part. So you could do more with the table if you wanted to, but this is what my graph looks like for the rest of it. Okay, interesting. Now, this part, you hopefully are getting the pattern. Horizontal line, parabola. This is a linear equation. It will look like a line. What I want to do is put in the 2. Let's do this one. We'll do in purple. So put in the 2. -2 plus -2 times -2 is equal to -4. Plus 3 is equal to -1. The point here is going to fill this one in. Okay, so that one, the endpoint of that, also fills in the other one here because they connect. Now I'm going to use my slope down to 1, 2 over 1, down 2 over 1, and draw a line using that slope from that beginning point. So this is a tough piecewise function, but just a reminder, do each piece separately. Remember that this is horizontal, this is a parabola, this is a line. When you have these other points here, go ahead and use the ends of the intervals to help know where to start and stop your graph. So we've done systems of equations. We've used that to solve equations for x. We've also reviewed over our graphing that we've been using so far in this chapter.